So firstly, my name is Renier. I'm from South Africa. I apologize for the rugby. All right, so today I'm going to be talking about Lustre and the cloud and some applications on the cloud. And when we're looking at complex workloads, it's very important to first understand what those workloads are before moving to the cloud. It's got quite a few cost implications if we don't. So I'm going to be talking about the SAS 9.4 application. It's used by financial institutions mostly, and it requires Lustre, obviously, as the file system, and we're implementing this on Microsoft Azure. So this is based on a white paper that was done with Microsoft. So there's the QR code if you want to have a look at it in more detail. Okay. Before we get into the study, let's first have a look at what the applications are. So SAS is a data analytics software, and it primarily looks at Monte Carlo simulations to model risk for financial institutions. So here's a nice picture of what a Monte Carlo simulation would look like. Each of those plot lines would be a task, so very nicely and easily parallelizable. So that lends itself to clusters, but that means you need a really, really good file system to be able to access all of the data as you need that. Before we move on to the actual analysis, I wanted to talk a bit about Azure itself. Not everyone might be aware of the different cloud infrastructure. So in a cloud infrastructure, you get different types of virtual machines. And they're pretty much set. You can't really choose the different ones. It's quite important what you choose. You can go all the way to this side, which is the high-performance computing side. It's the biggest, most powerful. It's got InfiniBand, but it's very expensive. So it starts from $580 a month per virtual machine. You can go all the way to the left, which is the D in a general purpose virtual machines, but you're not necessarily going to get the performance. So choosing which virtual machine is quite important, and we're going to have a look at the E range, and why we're looking at that will be apparent in a little bit. The other important thing to note is that compute has a cost, but storage has got even more of a cost when it comes to cloud applications. So if we have a look at just normal hard drives, so I don't know if you can read it all. The top line here is normal magnetic drives. 32 gigs will give you $1.50 a month. But this application requires 380 terabytes. So that's $12,000 a month just for the storage. So that's magnetic drives. Now, if you want to get faster and more performant, SSDs, same analysis, gets you to $29,000 a month. So if you go to premium SSDs, which gives even more performance, that's $45,000 a month for 380 terabytes. So just to keep those in mind. So why the cloud? The client pretty much had a cloud-first strategy, and they wanted to move all their workloads pretty much to the cloud. So this is a financial institution. There's certain benefits to moving to the cloud. It's adaptable. You can script. You've got service level agreements. So there's quite a lot of reasons why the organization chose to do that. And this application is then just moving one of those workloads. So there are two main requirements. The first was that SAS requires 150 megabytes per second per client connected core or per task. So that is the minimum data throughput that you need. And then the second one was had to be as cheap as possible so that you don't break the bank. So this was a bank, but they were they're cost sensitive as well. So 150 megabytes per second and as cheap as possible. So when we looked at implementing the Lustre solution for them, chose a standard out-of-the-box solution with your normal clients, a combined management server and metadata server, and then your OSSs as well. I'll go into a bit more detail on each of these components and then just talk through some of the choices around that. Okay, so let's just look at the first left bit, the clients and the MGSs. So Red Hat 7.7 was chosen. Just to put this in context, this was done at the start of COVID, so it was a couple of years ago. That was the operating system that was supported on Azure at the time. The virtual machines that we chose to test was the E range, so E16 just means 16 cores, and the E8, which is 8 cores. There were a total number of 24 clients in the system. And importantly, this is most of what the analysis was about, was the limits of the virtual machines. So a virtual machine has actually got its own data throughput limit, and it's throttled. Besides the hard drives, they've also got their limit, and the networks. So it's quite important to note these limits over here. So the E16 has got 968 megabytes per second limit per virtual machine, and so the E8 as well. And then the metadata server, the MGS, we used Lustre 2.12.5, the community edition, and we did use a premium SSD just for the metadata storage. Okay. The virtual machine that was chosen for that was also a more beefier one. It was the E32, so 32 cores for that system. For the storage servers, the E16 was used, once again the Red Hat 7.7, and disk encryption, I'll talk a bit more about that a bit later. The total size of the storage was 384 terabytes. More importantly was there were 2 disks per OSS, and the reason for that was that each disk had a certain amount of throughput, and if you have 2 disks, that's still below the virtual machine throttle, but if you have 3 or more disks, that actually exceeds. So it doesn't make sense to have more disks to your virtual machine. So we only chose 2 disks for the OSS. And then once again, I've got the throughput limits put over there. And another thing to point out, that the network was only 8,000 megabits per second. So it's not a fast network. It's not InfiniBand either. Okay. So the throughput tests we ran made use of SAS's own testing facility. So that's their script. It's pretty much a DD script that mimics the performance of SAS, then distributed over all of the clients. Another thing that we did potentially have a look at, being a financial institution, they're really sensitive about data, was encryption, but we left that. I mean, the reason we left it was it impacted performance too much if we did encryption on the fly. Okay, so to the actual results. There's 2 graphs here, one on the left and one on the right. This dotted line is the performance minimum, that 150 megabytes per second. And we did 2 tasks per client, so 2 SAS tasks per client. And you can see this 8, 16, and 24, and that all met the performance. So that's the E16. The E8, you can start seeing throttling. That's the same level there. So it just sort of made that with 2 tasks per client VM. We then ran this again with 4 tasks per client, and you can start to see that with running more and more virtual machines on the system, you don't actually get that throughput, so it starts failing. The same thing again. You can see there's no throttling on the read, but on the write, there was quite a bit of throttling. Okay, so some of the things we learned since the start of COVID and this being implemented and running for a few years was that in a cloud environment, things don't just stay on, they can actually reboot. So we changed it to a high availability cluster. So that if things do reboot, you actually get failover. You need to actually account for failover. One of the other things we considered, there was new virtual machine types, so we could go to a smaller and save cost. And the other one was Microsoft Azure supplies a Lustre service, an actual managed service, but it's quite expensive. So the client has to make that trade-off. Do they manage it themselves, or do they actually get, and don't pay as much, or do they get Microsoft to manage it for them? Some of the lessons we learned. In the cloud environment, there are so many different variables. One of them is something called a proximity placement group. That groups all of your virtual machines together so that you reduce the latency. Disk encryption almost stopped the project. Because it's a financial institution, they wanted to have the encryption keys for the hard drives. And at that time, Microsoft were the only ones who had the encryption keys for the disks. Luckily, 3 weeks later, Microsoft allowed the clients to manage their own encryption keys. So that meant that if an employee of Microsoft comes along, pulls out a hard drive, they cannot read that data. The other one was compliance, and IT management is still needed, regardless of whether it's on cloud or on premise. And that's pretty much me in conclusion. The performance was achieved with the cheapest hardware and the required throughput, and the benefit of cloud being flexible helped us quite a lot with that. Thank you very much.